Imagine holding a piece of copper in your hand. It feels cool, solid, calm, like nothing is happening at all. But inside that still metal, there is chaos. A riot silent, invisible, fierce, and it follows one simple, elegant rule, like repels like, unlike attracts. That's all. From that single rule, everything about electricity can be understood. Everything. Inside copper and all matter, there are atoms. Picture each atom not as a tidy solar system, but as a crowded hall, protons at the center. Electrons orbiting, restless, moving, pushed and pulled by that rule. Protons are positive, electrons are negative. Attract, repel, nothing more. And here's a secret. We do not know what charge is. We only know what it does. Positive, negative, attraction, repulsion, labels, names, the essence, the reason it exists, unknown. Now imagine other materials, rubber, glass. Electrons there are prisoners, tied to their atoms, unable to move. These are insulators. They cannot carry electricity. Copper is different. Its outer electrons are free. They drift, wander, flow. Nomads in a metallic landscape. Wrapped in rubber, copper forms a path, a river for electrons. Contained, guided, unstoppable. Electricity needs a reason to move. A push, a force. Think of a tilted pipe of water. Still, calm, no flow. Tilt the pipe. Elevate one end and suddenly water rushes. Voltage is the tilt for electrons. A battery is the pump. It gathers electrons at one end, creating a crowd. It leaves scarcity at the other. Connect the two ends with a wire, and the electrons rush. They move to equalize the difference. That movement is electric current. But it is not smooth. Electrons bump into the fixed atoms of the wire. Each collision transfers energy, makes atoms vibrate faster. That vibration, heat. A thin wire has more resistance. A thick wire has less. Force current through a high-resistance wire. The atoms vibrate violently. They glow. That glow is light. A light bulb. A wire bad at its job. Glorious. Electricity is not modern. It has always existed. Chemistry is electricity. Atoms bond. Electrons dance. Wood burns. Electrons find new partners. Nerves fire. Electrons move in waves. Life itself is electricity. Hold two ideas in your mind. One, the electrical force is unimaginably strong. Stronger than gravity. By orders beyond human comprehension. A tiny imbalance in electrons in your body and in others. Enough to lift the earth. Two, you feel nothing. Because charges cancel perfectly. The balance is exquisite. This is why matter feels solid. Your hand on a table. The electrons repel. You feel resistance. You feel solidity. But it is invisible. It is silent. It is electric. Ancients only noticed amber and magnetite. Rubbed, attracted, repelled. They touched the fundamental glue of the cosmos. Unseen. Invisible. Perfectly balanced. Electricity has a twin. Magnetism. Different in effect, same in essence. Electrons moving in a wire create a magnetic field. Move a magnet near a wire. Electrons flow. Motion becomes electricity. This is induction, the principle behind every generator. A river spins a turbine. A magnet moves. The motion transforms into electric current. Light flows. Energy travels. Life continues. James Clerk Maxwell discovered something deeper. A changing electric field creates a magnetic field. A changing magnetic field creates an electric field. They sustain each other. A self-propagating wave moves through space. Maxwell calculated its speed. Exactly the speed of light. Light is an electromagnetic wave. The warmth of a fire. The colors of a screen. X-rays, radio signals, all are the same phenomenon, oscillating at different rhythms. We live in an electromagnetic ocean, and we see only a sliver. Electricity is everywhere. It flows in atoms, molecules, nerves, and stars. Every spark, every glow, every current. A riot tamed by nature, and yet still a mystery. Now, think about this. Everything you touch, everything you feel, is held together by electricity. Your body, the chair, the floor, all atoms dancing their silent dance. Protons, electrons, repelling, attracting, perfectly balanced. Invisible, yet powerful beyond comprehension. Even the power of a nuclear explosion is electricity at its core. Inside a uranium nucleus, protons are crammed together. Their mutual repulsion is enormous, held only by the strong nuclear force. Split the nucleus, and the electrons are unleashed. A sudden, catastrophic release of electromagnetic force. And that, at its essence, is what we call a bomb. Electricity is the foundation. It is the pattern beneath energy, matter, life. We describe it. We measure it. We harness it. But do we truly understand it? We understand what it does, but not why it exists. That is the mystery. And that mystery is beautiful. Now, let's return to copper. Those free electrons wandering through the metal. They carry energy. They carry potential. They respond to voltage, flow through circuits, light up bulbs, spin motors. Yet, they obey a simple rule: attraction and repulsion. Simple, elegant, absolute. This is what Richard Feynman revealed, not by memorizing formulas, not by reciting textbooks, but by imagining, by asking questions, by watching the invisible. He asked, what happens if electrons move like this? If voltage pushes here? If electrons collide with atoms there? And he visualized it. He turned abstractions into pictures in his mind. This is the genius of understanding. Not knowing all the equations by heart, not parroting definitions, but seeing, feeling, imagining. Electricity stops being a concept. It becomes real, and the world changes. When you understand electricity this way, suddenly everything makes sense. A light bulb glows. A fan spins. A battery powers a device. Not magic, not mystery. Pattern, rule, principle. And yet, there is still wonder. Even with everything we know, electricity hides its ultimate secret. Why does charge exist? Why do protons and electrons obey this rule? We don't know, and perhaps we never will. But knowing how it behaves allows us to create, to build, to illuminate, to move, to communicate across continents, to capture energy from rivers, wind, and sun. This is the beauty of physics. It reveals how, not why. It exposes the patterns. It shows the rules. It opens doors to exploration. Feynman said, physics is like sex, sure. It may give some practical results, but that's not why we do it. The joy is in the understanding, the curiosity, the play. And that's what electricity teaches us. It is a play of forces, a dance of charges, a riot tamed into flow, and that dance underpins everything. Me, from the warmth you feel when you touch a cup of tea, to the spark of lightning across the sky, from the nerve signals in your brain, to the current lighting your city streets, it is everywhere. And Feynman's insight was not in showing something new about the equations. It was in showing how to think, how to see the invisible, how to translate abstraction into imagination, to take electrons, protons, voltage, current, and turn them into stories in your mind. Stories you can feel, stories you can touch, stories you can live inside. That is why learning electricity the Feynman way is not about memorizing. It is about seeing, imagining, asking questions, playing with ideas until they make sense, until they are obvious, until they become part of you. This approach does more than teach physics. It teaches thinking, it teaches understanding, and it teaches curiosity. Curiosity is the spark, the electron that moves, the force that drives exploration. Every great discovery starts with curiosity. Every invention, every idea, every step forward. And it starts with asking what happens if. What if I push the electrons here? What if I tilt the pipe? What if I imagine myself as tiny as an electron? What will I see? What will I feel? Feynman did this naturally. He didn't see equations first. He saw movement. He saw patterns. He saw electricity as a living, moving phenomenon. And from that, the mathematics followed. The equations became reflections of reality, not mere symbols. This is the key lesson. Electricity is not just a subject to study. It is a story to experience, a story told by nature. And by learning to read it, we become participants in that story. We become explorers. We become thinkers. Not just students memorizing terms, but interpreters of the universe. And that is what Feynman wanted for everyone. To look at the world. To ask questions. To see what others overlook. To play with ideas. To find clarity in the invisible. And that is the genius. The way he decodes electricity.